Hi everyone, my name is Kanishka and I am a student of Engineering Monk. Under the guidance of our CEO, Mr. Santosh, and our founder, Mr. V. Lognathan, I have developed a web app named as Stegnogram. But before speaking about what my project is about, I would like to explain the problem statement that I would like to solve. If you see, in modern world, we are shifting towards a digital, we are moving towards a digital shift. From words, from words, we are shifting into text. Like every handwritten documents is getting converted into digital. So we are living in a digital world. But when we live in a digital world, another problem arises with it, which is digital security. So my exact problem statement is that in modern world to provide digital privacy and security, we have various encryption methods such as E2E encryption, that is end-to-end encryption provided by WhatsApp, Signal, everything. But even though that is vulnerable to get hacked, so even such type of data can get hacked. And also there is also during 2019 and 2023 several spyware and malware have attacked WhatsApp, and around 350 millions people have data have get lost and hacked. And also the metadata leaks is be getting very prominent nowadays. So to solve all the solution, I would like to propose Stegnogram. Stegnogram is a double layered digital security protocol. Now, how it works is basically it has two layers, as I told before. One is AES encryption layer. AES stands for Advanced Encryption Standards, and next a steganography layer. But now let's see what each of them is one by one. So now you see, let's take an analogy example. Let's say there are two friends and they have to share some message, but they feel that security is utmost important and they decide to share them by sharing them numbers. Like friend A will share some numbers to friend B, and with those numbers, he or she will decode that and they will come to find out that message. So similarly, that's how AES works, but in a higher level. So AES creates every message different combinations and it converts them into something like this, which you can see on the screen. So this text you can see is known as ciphertext. A simple plain text, which is hello friend, is converted into this text, and this contains 256 bits, and that's why it is called as AES 25 256. And while doing it, it creates around 2 to the power of 256 combinations. That is, there are totally around 1.7 into 10 to the power 70 combinations in this, which we will be talking more briefly in coming part. Next, I would like to explain what steganography is. If we take the last analogy, in that if the friend decides to keep those message in an envelope so that it gets more secure and not vulnerable to anyone, so that's what steganography is. So steganography hides a text or a cipher text into an image by altering the least significant bits, that is the rightmost part of your pixel value. So by doing so, it will hide those text into the image. And when you saw the raw image and the image that has passed to steganography layer, you can't find any difference. So if you find this example here, both these pictures are similar, but you if even with not even with naked eyes or not even with forensic devices, you would be able to find any differences right here. Here for example, you can take the image on the screen, both contain same, but you can't find that much difference. Even forensic devices can't find such differences. And would you believe that this image here contains a message? So that's how steganography works. So now you may ask, like, how it protects users from vulnerability attacks. So basically, instead of sharing or storing simple messages in database such as other prominent providers like WhatsApp do, we can store images. While storing images, hackers will not be able to know whether it is a normal image or a stegno image. So this reduces the chances of getting hacked. And even though if they try to hack, they have to hack the passphrase, And while doing so, they have to put around 1.16 into 10 to the power 77 combinations. And even with the supercomputers we have, it takes them around 10 to the power of 38 years, which is more than the age of universe. And also some stats and tests have also shown us that the vulnerability probability for this protocol Stegnogram is only 0.001 percentage. And also these standards and percentage was calculated by the National Institute of Standards and Technology. Like we took inspiration from them and then it is calculated. Now you may ask what is the real world applications of this Stegnogram is. But before speaking about that, I would like to demonstrate how Stegnogram actually works. So here if you see, this is our user interface. Here you will have two options called encode and decode. So first, if you choose it asks you to choose for a file. And if you choose for a file, and you can type some secret message over here. And if you click on encode and download, it will give you a passphrase. So this passphrase has 16 characters length. And even to hack this, it took around, it has, we have to make sure that we put millions of combinations. So first, even for hacking this passphrase, it takes them for around millions of years. And after that only, they will be able to crack the image. And even though if they crack the image, it takes them around billions of years to crack open the message hidden in it. Now first let's download them and let's try decoding it. Now we have to choose the file that we have encoded, which is right here. After this, we have to paste the passphrase, and when we click on decode, we get the message. So yeah, but now you may arise a question: how can we copy and paste those passphrases each and every time? But when I create those in this applications, which is secure chatting or digital voting system, all those passphrases will be stored in a secured database system such as Supabase. So for every message or for every vote, such passphrase will be stored in Supabase and it will be retrieved automatically based on messages. So this ensures furthermore security. So not only these two, it can be also used in military intelligence, legal evidence transfer, and digital authentication. And also, I have emphasized this in digital authentication because recently our Aadhaar data has also got hacked. So now moving forward, I have shown you the demo of this application. And then if we talk about the impact it has, firstly, it is first of all invisible and encrypted. And this reduces the risk than modern encryption methods. And also to speak about its contribution towards Viksit Bharat, it contributes a lot because Viksit Bharat is mostly dependent upon developed India. And if we have our own technology for digital security, then that automatically increases our economy and contributes to our GDP. And that's how it contributes to Viksit Bharat and self reliant Bharat too. So with this, I would conclude. I would like to conclude with the technical stack. I used Python for the processing engine, which is the steganography engine, and HTML, CSS, and JS for the front end, and the least significant bit algorithm, along with Pillow and cryptography for further processes. Then I would, if we have to talk about the limitations, the main thing is that storage. If we have to store some text in database, it takes only around bytes of data. But when we have to store images, it takes MBs of data. And I'm constantly working towards it to make it scalable and efficient. And at last, I would like to acknowledge my mentors once again, Mr. V. Santosh and Mr. V. Lognathan. With this, I would like to conclude. Thank you.